True to its nature, the definition of data science is as wide and as varied as the data processed in this discipline. Some would say data science is the science of big data, but what is big data? And how big is big anyway? Perhaps the best way to define data science is to take a look at who data scientists are. Drew Conway, the CEO of Alluvium, uses this Venn diagram to efficiently explain the core competencies of a data scientist. For Conway, a data scientist should thrive in the areas of hacking, math and statistics, and should have substantive expertise. He uses the term hacking loosely as to mean being able to manipulate text and command line, understand vectorized equations, and think algorithmically. The third component, substantive expertise, is critical for the formulation of motivating questions that could be tested and analyzed using statistical methods. Conway's Venn diagram, however, misses a very important component of a data scientist: communication and visualization skills. The true value of data science is only realized if the insights and recommendations are implemented. It is therefore critical that a data scientist be able to explain complex results to non-technical stakeholders to ensure project buy-in. From these key takeaways, we can then define data science as a multidisciplinary field that uses computing and statistical methods and algorithms to extract knowledge from various sources of data in order to solve real-life problems. TJ Patil and Jeff Hammerback claim to have coined the term data science in 2008 to describe their jobs on LinkedIn and Facebook, but one of the earliest recorded usage of the term dates back to as early as 1960s by Peter Nauer and later again in 1974, where he alludes to data science in his research for contemporary data processing methods that are used in a wide range of applications. Since then, definition as well as the field itself has evolved and expanded to what we know today as the sexiest job of the 21st century, thanks to Harvard Business Review. In essence, data science is only new primarily because it's only now that we've managed to acquire data this big in volume that traditional scientific methods of analysis fail to be useful in most circumstances. The decline in prices of data storage and computing hardware has enabled the boom of the dot-com industry. Before Facebook and Google, it took thousands of years before humanity was able to generate the amount of data we produce each day now. Today, industries such as banking, retail, logistics, medicine, and healthcare leverage data science to support their operations and increase their profit margins. One example of a successful data science implementation in non-tech industries featured in Harvard Business Review is that of an unnamed American sports league. By taking into account thousands of variables as constraints, they were able to reduce their expenses by optimizing their game schedules. They were also able to significantly lessen player fatigue by reducing their travel time and the number of games they played consecutively. This also allowed each team to appear on the league's premier TV at least once in the season, increasing their engagement time with the fans and generating more revenue streams. The two factors they identified as keys to their success are having a clear strategy and a strong commitment across the organization. In these types of digital transformation, leadership must be heavily involved and recognize that tough decisions must be made from the insights drawn throughout their journey. While most of the C-level executives are initially supportive of their company's digital transformation initiatives, these projects fail 60% of the time, mostly because of a misalignment between expectation and reality, and the lack of fundamental understanding of the main tools of data science: artificial intelligence and machine learning. When we think about artificial intelligence, the first thing that comes to mind is probably the Hollywood version of it: human-like cyborg terminators and self-driving cars. In reality, AI is simply any device or system that mimics the cognitive functions of the brain, such as learning and problem solving. It can simply be the computer player you're up against in a video game, or it can be as complex as Sophia, the first humanoid robot granted citizenship by the Kingdom of Saudi Arabia. Or it can be one of the more practical applications like fraud detection algorithms used by financial institutions and even social media. Machine learning, on the other hand, is a subset of AI. ML algorithms allow systems to learn automatically using pattern recognition and inference without human intervention and adjust accordingly to the situation. One such model, the artificial neural network, mimics the neural network of the brain to allow problem solving just as the human brain would. These kinds of inference patterns allow faster analysis of massive amounts of data where it's not practical to develop algorithms to perform specific tasks. Some applications of ML are email filtering and cybersecurity. Recommender systems present in websites and applications such as Netflix and Tinder also employ machine learning to improve user experience. While these are just tools to implement a data science initiative, it's important to understand them in order to set expectations, especially with regard to return on investment, whether it be on people or on systems. At the end of the day, we must put into perspective that we are not investing on technology for the sake of technology itself, but instead we are investing on answering the most pressing problems we have.